Hello everyone. In this session, I'll discuss an interesting topic. What is multi-cloud development? So multi-cloud development basically tries to address one common concern. How can I build application once and deploy on any cloud platform or virtually any environment? As I mentioned in one of the earlier session, we have over 100 plus services offered by various cloud platforms. So how do you build cloud applications so you are cloud neutral and get the flexibility to choose and deploy on any cloud platform without any changes or with minimal changes? So, as I mentioned in one of the earlier sessions, you need to adapt multi cloud development for various reasons, be it agility, avoiding vendor lock in, affinity for a particular cloud platform from your customers, or maybe a disaster recovery strategy. So, let's look at some of the principles you should apply to be multi cloud ready. And some of this strategy might look advanced based on your expertise and experience, but it is helpful to keep those in mind as and when you develop cloud applications and be familiar with this topic. I'm calling this out as most of the concepts I've tried to keep it simple, but in certain cases I'm bringing in advanced concept to help educate and keep these practical aspects in mind while building cloud applications right from designing of the cloud application. So let's move on to the first principle. The first principle is around design for containerization. Now, as part of the step, you leverage container based development and make software applications as independent units that can be deployed in any cloud environment, supporting container management services like Google Kubernetes Engine or Azure Kubernetes Service or Amazon Container Managed Services. For those who are not aware of what microservices are, it's basically an architecture style to break down large applications into loosely coupled services that can be independently deployed and scaled. Like take an example of a banking application. Microservices would comprise of various transaction services like credit card transactions, domestic bank to bank transfer, international transfer, and so on. And if you like to know more about how the technology trends, for instance, how technology trends have evolved from monolithic to web services to SOA, microservices, containers, CI/CD, DevOps, and cloud neutral has evolved over the last 2 decades. Do check out my YouTube video where I've talked about how the technology has evolved over the last 2 decades. The next strategy is to be cloud agnostic. Now, as I described earlier in the cloud platform session, there are hundreds of compatible services offered across cloud platforms. But compatibility doesn't always imply interoperability in all cases. For instance, if you take an example of a NoSQL database, you can use open source distribution like MongoDB instead of using compatible versions offered by AWS like DocumentDB. And there might not always be 100% portability across services, so you need to be aware of any limitations or features that are not supported by looking at the cloud vendor product documentation. So you need to select the right services and evaluate trade-offs based on your application requirements. For instance, for a relational database, you could choose PostgreSQL, SQL Server, or MySQL. And these are widely supported on all cloud providers. Secondly, pickup services where managed offerings of open source version are offered by cloud vendor. Like you could use Prometheus, which is an open source monitoring tool, and use Google Cloud Managed Service for Prometheus for Google Cloud, or Amazon Managed Service for Prometheus for AWS Cloud. So this ensures a migration path if you choose to move to a different cloud provider. And in cases where you need to go with a proprietary cloud service, follow the third strategy, which I'll talk about later, called API abstraction. So the third strategy is around API abstraction. Now, as you build a real world application, you might not always get the liberty and flexibility to choose a service that is 100% compliant across cloud platforms. So, how do you ensure flexibility and can change services with minimal changes? So, what you can do is you can design and create well defined interfaces and APIs as the level of abstraction between your application and cloud services. For example, instead of using an API for a cloud service directly, you can create your own generic API, and the generic API can call the cloud specific API. And your application always deals with the generic APIs that you have created, providing you flexibility to change the implementation without affecting the overall application. The next strategy is around the data lifecycle strategy. So, data from a regulation perspective can be broadly classified at PII or non PII. PII stands for Personal Identifiable Information. Example of PII data are identity details like SSN number, passport number, contact details, and basically any piece of information that can help identify an individual directly or indirectly. And based on data sovereignty and regulation, the PI data cannot leave the geographical boundary. Like personal data from Europe region can't reside in India or US. And there are other set of data like analytics, click-through data, general non-PI data like geography, age ranges, which you might require for downstream processing, either for analytics or let's say training an AI model for generating insights. So the idea is to decouple the PII and non-PII data right from your design. For example, through unique non-PII identifiers for your primary data. So storage and processing can happen independently. And this decoupling is important because it provides flexibility to use required specialized cloud services and regions for non-PI data and even from other cloud providers and avoid vendor locking. While PI data runs on a given cloud region and provider as per your data regulation requirements. And the last strategy is to standardize on DevOps tools. For those who are not aware of DevOps, DevOps is basically a methodology on how can you build, develop, and deploy applications consistently and have a tight collaboration between developers developing the application and operating team deploying, securing, and monitoring the application. And CI/CD, which stands for continuous integration and continuous delivery and continuous deployment, provides the methodology and tools to make it happen. Like Jenkins is one of the open source tools for CI/CD, which is used in conjunction with source repository and version control applications like GitHub. So for CI/CD, ensure you use open source tools like Jenkins and monitoring tools like Prometheus to provide a vendor neutral DevOps and monitoring process across your cloud provider. And for more details on what is CI/CD and DevOps, please do check out YouTube video. The link is provided on the screen. So this completes our multi-cloud strategy. In our next session, we will look at a typical lifecycle deployment of a cloud-based application. Till then, happy learning.